Since the last video about my house, I sharpened my pencil a little bit more and got my load down from 2.5 tons to 2.2 tons by shading my windows, since we were probably going to have blinds and curtains anyway. My total airflow is now 895 CFM at this load. Now it's time for me to select my equipment. I was really torn between two different approaches, a Bosch IDS 17.5 SEER and a Carrier Greenspeed 5-stage. Both have inverter compressors, but they control the compressor speed in two very different ways. The Bosch uses an ECM 2-stage blower that you would wire up to a typical 2-stage thermostat. The compressor is programmed to make a 47-degree evaporator coil, so it can just ride with the load and airflow settings and still provide very efficient cooling. It can also run on an Ecobee thermostat or any conventional thermostat. You can also turn on what Bosch calls enhanced cooling with some dip switch settings. Also noteworthy is Bosch only makes a 3-ton and a 5-ton condensing unit. The 3-ton can be set to 2 tons with another dip switch. It offers a 2 and a 3-ton air handler to match with that condensing unit. The Carrier is a fully communicating system. You must use its Infinity thermostat to get all the features out of it. Bryant and ICP are sister brands that also have the same technology under different trademarks. Bosch publishes its performance specs for normal mode only. I could not find performance specs for enhanced mode, while Carrier publishes two different modes, efficiency and dehumidification mode. I was really in between a 2-ton and a 3-ton. We always teach students to size their systems aggressively and avoid oversizing equipment. The standard for selecting which tonnage to use would be Manual S from ACA, which says that equipment has to be within 90% and 130% of our sensible load if we're using a variable speed compressor, and we must meet or exceed our latent load. So I created this spreadsheet to compare the two brands at the same design temperatures and similar airflows at 2 and 3 tons. The Carrier 2-ton would not need the sensible load, so it was out. The Bosch 2-ton met my sensible load, but it did not meet my latent load. The only way it would meet it would be with a humidifier. And I didn't like the idea of relying on the dehumidifier during peak design conditions to remove moisture. So per Manual S, these 2-ton units would not work. At 3 tons, both systems comply with Manual S in sensible and latent capacity. Now let's pause for a minute and compare the performance between the Carrier and the Bosch. The Carrier absolutely crushes the Bosch in latent capacity, which is its ability to remove moisture. The Bosch makes up for that shortfall in more sensible capacity. The reason is the Carrier runs a very cold evaporator coil, and it can really wring out the moisture from the air. Now remember, there is an unknown here. The chart only lists the Bosch's capacity and performance in its normal mode. When we set it to enhanced mode, it's going to allow the compressor to pull the evaporator temperature down to around 43 degrees, but that's still probably not as cold as the Carrier. So even in enhanced mode, the Bosch probably closes the gap a little bit, but it still seems to be more suited for sensible removal. Head-to-head, the Carrier simply outperforms the Bosch in almost every category except for sensible capacity. But what happens when the sensible load drops? But there's still a lot of humidity in the air. And that's very common in the South, and especially for me, since I'm near the coast. There'll be plenty of hours when it's in the 60s or 70s outside, but a high dew point temperature. Because the Carrier is fully communicating, it can independently adjust the airflow and compressor speed to dehumidify very well. And it also has a reheat dehumidification feature, which will cycle the electric strip heaters to avoid overcooling the space while it continues to dehumidify. It's very impressive. But remember, strip heaters are running during cooling season, which is going to make my power bill go up. The Bosch does not have that capability. It only has 2 evaporator fan speeds and will maintain a constant evaporator temperature. So just like single and 2-stage equipment, there will be plenty of times when it will have to cycle off on temperature when the latent load remains, but the sensible load is very low. So what do we do with that? We have to supplement it with a dehumidifier, and I prefer the Santa Fe Ultra series. But this is an additional piece of equipment that I have to purchase and maintain. And while it doesn't consume as much energy as the reheat strategy, even an efficient dehumidifier still uses power. So we are left with 2 choices. Either pay more now for an additional piece of equipment, that is the dehu, or pay more later over time with higher power bills. So how much more energy will this cost me? Well, there's been some really smart people who have done a lot of case studies, but there are also a lot of variables too. Where you keep your thermostat and humidity set point, how leaky the house is, how much ventilation you bring in, how many people live in the house, and what their activities are, these all affect it. The more latent load is on the house, the bigger difference we'll see. For my house, because I'm trying to minimize infiltration and only ventilating on demand, my latent load should be pretty low. So either option would be a good one. But I could see a scenario in a retrofit situation on an existing leaky house where installing a carrier with reheat would really make the energy bills higher. So good communication, setting expectations, and explaining the benefits of dehumidification are key so your customer understands what they're going to get. I also want to address something else. Researching equipment and making those decisions using spec sheet is the right way to select equipment. It's the foundation of Manual S. Case studies are very important and they're very useful. A lot of lessons can be learned and even interpolated from them, but they aren't apples to apples comparisons. We have to be very careful about taking case studies and making broad assumptions and conclusions across a bunch of climate zones. Alright, back to my house. There are a few other factors. Since I'm no longer a carrier dealer when I sold my last business, my pricing on carrier systems is significantly higher than my Bosch pricing. Perhaps carrier volume dealers could close this gap, but that gap is big enough for me to still be able to get a dehumidifier. And Santa Fe dehus have a great warranty and they're built to last. Another factor is that I would be stuck with a carrier communicating thermostat, and I just don't like it. I much prefer using the Ecobee. Plus, my plans for my house include using it as sort of a test lab for various strategies using the Santa Fe ventilating dehumidifier paired with the Haven IQ monitor and controller. And my options would be very limited with a communicating system since they don't use conventional 24-volt controls while still being able to give you all the features. Finally, I was very worried about the maintenance record of the carriers, the cost and availability of parts as well. When I compared a replacement fan motor, control board, and other parts, I didn't get a warm and fuzzy feeling with the carrier. And being a former carrier dealer myself, I personally had some bad experiences with really long lead times. And because I'm spray foaming the attic deck, I'm going to need a dehumidifier anyway. Another video will come out about why that's the case. So ultimately, I chose the Bosch with a Santa Fe ventilating dehumidifier for my house. But I want to reiterate, the Carrier GreenSpeed is a great way to combine cooling and dehumidification. So if you're going to sell a communicating system, there should be no reason to also sell a dehumidifier. The GreenSpeed can do both. So just be careful in humid climates like the South and set expectations for possible higher energy bills. And if you are installing single or two-stage equipment, it's best to offer a dehumidifier option with it. Let the owner turn it down if they must. Returning to my house. Now that I've selected my system, I next go into RightSoft and I enter in the performance information from that expanded cooling chart so it can interpolate it for my exact design conditions. This will verify that I'm compliant with Manual S for sure. The same goes in heating mode. I enter the heating capacity of 47 and 17 degrees outdoor temperature, and it interpolates what my capacity will be at my exact winter design outdoor temperature. Then I know how much auxiliary heat to include. In this case, it's around 8 kW. The last part of my selection process was to select the fan speed at which my design airflow would be met. The Bosch 3-ton air handler can make slightly more than my design airflow at 0.5 static pressure at speed tap 4. That gives me a little bit of wiggle room if I need to speed up my fan. You never want to design a system that has to be maxed out to make the right airflow in BTUs. You always want a little bit of wiggle room up or down. So I'll make that my second stage airflow, and I'll set my first stage airflow at speed tap 2, but I can always adjust these later. As you can see, the equipment selection process is just not an automatic thing. You can't just take your manual J and turn it into a unit tonnage. With this selection, I'm comfortable that this system will maintain my temperature and humidity while not spiking my energy bills. How do you size and select a dehumidifier? I'll cover that in a future video. Now that we've completed manual J and S, we are ready for our manual D duct design, and that'll be my next long video in this series. Thanks for watching.